This is section 12, sine, cosine, and tangent for Honors Math 1. To start out here, we want to look at the definition of trigonometry. Trigonometry is a branch of mathematics. We are going to study, first of all, how trigonometry applies to right triangles. And in right triangles, trigonometry is the study of relationships among the triangle's acute angles and the side lengths. So to get started here, what we want to do is we want to look at triangle ABC. And to use the trigonomic ratios of sine, cosine, and tangent, we need to understand in this direction it says to use angle A. So from angle A, we need to label the opposite, the adjacent, and the hypotenuse, and abbreviate those OPP, ADJ, and HYP. If I was using angle B, then this would be my opposite side down here, and this would be my adjacent. But as we've already discussed, hypotenuse is always the longest side across from the right angle. Once you have the opposite, the adjacent, and the hypotenuse labeled, then you can apply these ratios. The sine of an angle is always going to be the opposite divided by the hypotenuse. Cosine of angle A is always going to be equal to the ratio of adjacent divided by hypotenuse. And the tangent of angle A is always going to equal the opposite divided by the adjacent. To help us remember these relationships, these three ratios, we have a mnemonic device, and it's SOHCAHTOA, and that's SOHCAHTOA. And SOHCAHTOA helps us remember that sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is the opposite divided by the adjacent. So you have these three equations. So to get started with this example number 1, it says that we are going to look at angle P. We want to write the fractions for sine, cosine, and tangent. So on our triangle, we label angle P here. We label the opposite, the hypotenuse, and the adjacent. So opposite from P, adjacent, hypotenuse. And then we want to write the fractions that go along with those side lengths. So here, all the side lengths are given. We're not solving anything. We're just getting familiar with what these equations are going to look like. So using our mnemonic device, SOHCAHTOA, sine is opposite divided by hypotenuse, and so that fraction would be 15 over 17. Cosine is adjacent divided by hypotenuse, which is 8 over 17, and tangent is TOA, opposite divided by adjacent, 15 over 8. So what I'd like you to do here is to try these next 4 examples. You need to label the triangle and write your fractions in reduced form. So hit pause, try the next 4 examples. When you're done, hit play and see how you did. Alright, so on this triangle here from angle C, you'd have your opposite and your hypotenuse over here, so our fraction would be 12/13. From angle Q, 27 would be opposite, 36 is adjacent, 45 is hypotenuse. So cosine is adjacent divided by hypotenuse, 36 divided by 45, that would reduce to 4/5. On C, we have from angle X here, we have opposite, 48 is adjacent, 52 is the hypotenuse, 48 over 52 reduces to 12/13. And tangent from angle O, TOA opposite 28 over 45 adjacent. And that does not reduce. The last thing we want to do is check in our calculators and get familiar with these three trig functions and making sure that we can type them in. So on your calculator, if you do not have a graphing calculator, you just want to make sure that you have DEG showing for degrees. And then if you have the graphing calculator, you'd always want to go to mode and then scroll down and make sure that you're in degree mode. The normal mode is radians, how it measures, so you want to make sure you're in degrees, and you would just arrow down and then hit enter over degree. And I have these three typed in here, so the sine of 46 is 0.72, cosine of 17 is 0.96, the tangent of 60 is 1.73. If you are unable to get those three decimals and getting familiar with those buttons on your calculator, please let me know. So just to finish this out here, what did that mean when you got those values? Okay, well, why does the sine of 46 equal that? Well, remember what sine is, okay? If I have a triangle here with 46 degrees, opposite divided by hypotenuse, okay? If I have any triangle that has 46 degrees in a right angle, it's going to be similar to another triangle that has 46 degrees, okay? And so they're all having an equal scale factor, just like these. Some of these reduce down to 4/5, okay, or 12 over 13. Those are special right triangles, and without decimal sides. All triangles with a 46-degree angle here would always equal their opposite divided by hypotenuse will always equal 0.72. Okay, that scale factor. Cosine of 17. They would always, their adjacent divided by their hypotenuse would always equal that value that we got. So this gives you kind of an intro to trigonometry, and that concludes section 12 notes.